what exactly we have learned so far. So far we have no. Welcome back to the second part of the Kubernetes basic tutorial. Before we proceed, let's take a step back and understand what exactly we have learned so far. So far we have knowledge about like Docker basics. We know what are the pods, we know what are replica sets, and for the next steps we are going to cover one by one deployments, daemon sets and services. Now we are following a sequence here so that we can get to know different building blocks from the basics. That is why we are going from the smallest unit to the upper part of it. So smallest unit is pod, and from there then we are going to replica sets, then we are going to deployments, daemon sets, and then at last we are going to services. Now moving to deployments, what exactly it is? It is similar to replica set because in daemon set also you can run multiple pods as per replica set, but it has some added features. And when we talk about deployments, think about how the applications get deployed. So similarly, we can have different version maintained here. So let's say you have deployed something with a container image like nginx version 2 and you want to upgrade it to nginx version 3, you can properly maintain that using deployments. We will get to it in more details. So on a high level, there are like it has the capability of upgrading the underlying application using different strategies. So by strategies I mean like rolling updates, we have recreate, so this kind of stuff. By rolling update I mean, let's say you are doing a new deployment, and what it does is it creates the new set of your pods and then deletes the old one. So let's say you have 3 pods currently running right now with the same image. What it will do is it will create 3 new pods with the new image or container ID, but what it will do is it will create one to the new one and again delete one from the existing configuration. So at a certain point of time you will have one pod running on that side and one pod getting deleted on the last version of your application. And when we talk about recreate strategy, that is like deletes all existing pods that you have right now and adds new version of your application via pods. By default, if you do not specify any configuration in our deployment configurations, it will be rolling updates. Okay, now let's understand it a bit more into detail. Let's have some pictorial overview like what we have learned so far and what are the deployments we are talking about. So let me take an attempt of explaining it via, test it out first. Yeah, it works. Okay, so far we have came to know about pods. So we know when we talk about replica set, that means we have one pod, we have another replica of it, we have another replica of it, and this is replica set. Now we are moving ahead with the deployment part of it. So how does that work? Let me show you. Let me delete this one. So I am pretty new with this, so it might take some effort for me to get used to it. Okay, so let's say you have already deployed your application. So let's say you have like 2 pods running now and they have nginx version 1 and this is forming our replica set, and we want to use deployment to have nginx v2 push to it. So what we want to do is we want to create a deployment on top of it, and this is going to be our deployment. What it's going to do is whenever the deployment sees that there is a new version of my image, it will automatically create pods, 1 pod, 2 pod, and it will create these pods using v2, and it will create a new replica set, and eventually it will be terminating this replica set. So your users who were previously pointing to this replica set, this will be completely cut off and user will directly access this. I think this makes sense to explain like this. Please let me know if it does not work out that well. Do let me know in the comments so that I can correct it from the next time, or if you have any suggestion for it. Okay, now let's go hands-on and create a deployment. So similarly, I already have the configurations written here. Let's do one thing. Let's create again from scratch with the same configurations. So what we are going to do is we are going to create a deployment. So as I mentioned earlier, we have 4 key elements that we need to keep in mind. That is API version, we have kind, we have metadata, we have spec. Now here in API version for deployments, it will be app/v1 and kind will be deployment. And guys, these are case sensitive, this kind, so please take a note of it. If you're providing this in small letters, it will definitely going to throw an error. And in metadata, this metadata is completely on the metadata of the deployment. So we are saying like, okay, the name of the deployment is like my application, my app deployment, and let's add a label to it, app, my app. Now going to the spec, similarly we are following the same thing that we used to do in our replica set. So we will just go to the replica set and we can just copy it from here. This is extra. So we will just copy the entire spec from here. We'll go to deployment and we will just paste it. Let me see whether my notes are ready or not. Yeah, both of the notes are ready. I'll just paste it. Similarly, I'll just do kubectl apply -f deployment.yaml, and it gives an error. Let's see what it is. Unknown field label. So there is a typo there. So we will go back to deployment, and it should be labels, not label. We will correct it here. And we have the deployment created. How to see the current deployment? So kubectl get deployments. So we are seeing that there is a deployment here, and current status is ready 1/2. Let's wait for it, and meanwhile I can go back to that whiteboard that we were doing. So if you see, I was mentioning like whenever you create a deployment, replica set will be a subpart of it. So ideally the deployment should create a replica set automatically for us. So let's do kubectl get rs. You will see that there is a replica set, and how can we be sure that this replica set has been created by our deployment only? Look at this. It is the name of the deployment, and it has added a random suffix to it while naming the replica set. So similarly, this replica set will be also having our pods, right? So if I now do kubectl get pods, it should show this, the replica set name dash again an additional suffix of the pod. Let's do that, and you will see this is similar to what we have here, and then it has added a random string identifying each and every pod that we have. Now we talked about this is kind of easier if we are planning to deploy a real world application, right? It helps us to maintain different versions of it. Now we can check that. If we do, let's do kubectl get deployment. Let's get the name. This is our deployment name. Let's do kubectl and rollout history deployment slash, this is our deployment, and we will see that it's currently in revision 1. Now let's do one thing. Let's directly edit this deployment and apply something else. So we will just go and let's think that we are upgrading the image, so it's like nginx v2. Obviously this is going to fail, it's not going to be there, but we want to see that failure. And kubectl apply -f deployment.f, and it says like it's configured. Let's check the status of it right now. Rollout history, and you will see there is a new version, and this version 2 contains the v2 image. So let's see the current deployment status. Ideally it should fail. Yeah, it will try to maintain the same replica, and as I mentioned earlier that by default this configuration of deployment is rolling update. So until and unless we have one image healthy or one container or pod healthy, it's not going to terminate any of the existing one. So it's getting error every time. It's getting error, and it's getting like error image pool because that image does not really exist. So what we have to do right now, let's say we want to revert it back to the v1. So how we can do that? We will do kubectl rollout undo then deployment name, deployment/deployment name, and it says it has rolled back. Now let's see the rollout history once again. Every time when you do a rollout and when you do a undo, it's creating a different replica set, and what it will do is it will make sure that the version or the revision is also updated. We reverted back to revision number 1, but it will be counted as 3. It will not show you like, okay, we are reverting back to revision number 1. That's something to note here. Okay, now let's see whether that pod is still existing or it has been, yeah, the pod that we were seeing, this one doesn't exist right now. I hope this has given a basic overview what the deployment does and how exactly we can do that. Let's go to the DaemonSet concept. So DaemonSet is similar to deployment, but DaemonSet is mainly, it has certain use cases. Let me explain how exactly. Think of this as your entire cluster, and within that you have multiple nodes. Let's consider this is your master node, this is your master node, this is your node 1, this is your node 2. What DaemonSet is going to make sure that for each node that we have, it's going to make sure a certain pod will be present in everywhere. That is why in the configuration you do not have the replicas parameter in spec when configuring DaemonSet. Different use cases can be like a monitoring agent. For example, if you want to monitor the node logs or different logs that you want to collect from the actual hardware or virtual node, then you have to make sure the agent is already present and configured within that node, and DaemonSet suffices that requirement. So let me give an example. Let me go to the configuration. It has the same configuration as our deployment. The only difference is in DaemonSet we cannot have replicas, because it's DaemonSet's responsibility to make sure that each of these cluster nodes that we have, it will contain one pod, and if the node goes down, then that pod will be missing. We can't see that. Now let's say you are currently hosting your Kubernetes cluster in the cloud and you have an auto scaling group, so your node increases depending on your workload or your traffic. So what happens is, currently let's say you have a 2-node cluster, and certainly due to auto scaling it becomes 3. Then it's DaemonSet's responsibility to push that same pod in the newly brought up node. It will make sure that the new node is also having the same pod. The difference between the DaemonSet and the deployment configuration is just kind, and we just need to make sure that in spec we are not having the replicas. So let's copy it and let's put it there. I think I missed, yeah. kubectl apply -f DaemonSet created, kubectl get ds, and you will see we have not provided any replicas number, but it's showing desired as 2, current as 2. Why? Because if we do kubectl get nodes, we are currently running on a 2-node cluster, so we have the master node and we have one work on node, and if I turn one off, the desired will be 1, current will be 1. And similarly, if I just add a kube work on node 2, it will make sure the desired and current and ready all should be 3. Okay, it's currently in ready state right now. Okay, so far we have let me delete the DaemonSet. Okay, we have deleted that. So far we have only talked about pods, we have talked about replica sets and deployments, DaemonSets. Ultimately the motive was like we want to host our containers in a way via Kubernetes so that it's automatically orchestrated properly and we don't have any kind of like service interruption. Now a basic thing that we have to cover right now is services. What are services? Services are basically, it helps you to expose your application to the consumer. So for example, let's say here I am hosting this nginx image, right? So ideally it should give me a hello world or a basic page, so, and it will be used by the consumers. So similarly your application will also will be used by consumers, right? So far we have only created the pod, we have deployed it, but right now we cannot access my application, and for that we have service. There are mainly 3 type of services that we come across: NodePort, ClusterIP and load balancer. Unfortunately, since I am having this entire setup in my local system, I cannot show you the load balancer service type, because load balancer is more on a cloud native approach. So if you are hosting your Kubernetes cluster in AKS in Azure or EKS in AWS or GKE in Google Cloud, then when you create a service and if you specify the service type as load balancer, it will make sure that it will create a cloud native load balancer for you, and it will that load balancer will be connecting to your pods to redirect all the traffics. But here, since I am currently sitting in my local system, I can only give you a demonstration of node port and ClusterIP type. So let's go to the services. For services also, we are following API version, kind, metadata, spec. Here we are saying, okay, this is my service, and in spec we are saying like selector, app is equal to web. Now this is a very important field here. Now this selector ensures that this tag key app and value web basically goes to your specific container. So here also, if you see, when we created this, we are saying label app is web. So similarly, if we want to redirect our service or consumers via the service to the specific pod, we have to make sure we specify the correct selector here. And here we are saying like the protocols port and target port. So this port means like when you connect to that service, which port you should connect to. So in this case, think of it like this port is like where the consumers or the end users hit, and the target port is in which port your container is listening. So if I go back to my deployment, you will see that I have exposed my container on port 80. So this is the mapping that happens in backend. And here we are as of now considering the type as ClusterIP. Let me create one service as ClusterIP first, or node port first, then I am going to explain the differences between ClusterIP and node port. And it says the service has been created, kubectl get svc, and this is my service. It's giving me the cluster IP via which I can access my application, and the port is 80. So let me do a quick curl to this IP. I should see the nginx page. Yes, as you see, it's redirecting to my container, and that is why I am able to see the nginx welcome page. Now let me go back to the services and let me try to do the same thing, but this time we will do node port configured. And this time, if you see the differences between the last time and this time, is my service last time was ClusterIP, and this time it is type of node port. So let me try to access it. And if you look at it more carefully, you will see that there is a difference, another difference between ClusterIP and node port. Here you will see that there is an extra port mentioned here, but if you go to ClusterIP, you will only see one port. Now let's come back to that point. What exactly is the differences between these two? Okay, let's say this is my cluster. When a cluster is created, think of it like it has a internal networking configuration on a high level. Think of it like that. It has a networking router, a virtual router in place, and it automatically assigns an IP address pool to it. So when we talk about the cluster IP, and we have different, let's consider the nodes here as well, node 1, node 2. So here we have our pods here situated. I'm not going into that details like whether it's provisioned via replica set or deployments. Just think of a basic pods present in the both of these two nodes like that, and we are trying to create a service. So this is my cluster, this is my node 1, this is my node 2, and here we are defining a service. Now as I mentioned, there is a IP pull. What it does is when I try to create a ClusterIP type service, it just assigns one IP from it. So this IP will be connecting to your pod, and the consumers, they are going to access it via this IP. This is how the cluster IP service work. Now similarly, if we talk about node port, it's also kind of similar, but it has a catch. Think of this as our cluster right now, and here we have node 1 and node 2. Whenever Kubernetes creates a node or a node gets attached to it, a virtual IP address pool gets assigned to it as well. So this one has a CIDR pool, this one has a CIDR pool, and let's say it has 192.168.0.2/24, and this one has 192.168.0.1/24. When I specify a service here, let's say this is my service, what it will do is, and I specify node port, what it will do is this pod, it will directly go to this node and it will ask for an IP address. And I have already exposed my container on port 80. So what this pool will do is it will assign one IP address here. Let's say 192.168. Okay. It has assigned 1 dot maybe 100, and when we configure a service, we are saying it should reach out to 80. So basically when the traffic reaches, I am going to hit the port 80. Ultimately this 80 has to get redirected to this 80 that we have within the node. Now what it will do is it will come, this service will point to this IP, this one, and this guy will have one random port added to it. Let's say 1 2 3 4, and this mapping will be happening here. So what happens here, which mapping happens here? So user requests in port 80, next step goes to the node. In node it will talk to 192.168.1.100 colon 1234. And this 1234 basically interacts with my container on port 80. This is the entire mapping that we have, that we follow. So similarly for this one also, for this pod also, we will similarly have one IP assigned from this, and this traffic will be distributed here. Something happened here, I don't know how to delete that. Sorry, it's my first time, so I really have no idea how this, yeah, deleted. Okay, let's say this one assigns 192.168.2 2.1.0.0, port is 2345. This one is assigned here, and this talks to my container on port 80, and this service redirects here. I know it's a bit clumsy, but I'm just trying to explain it. Okay, yes, now there might be a question that you might ask, like if I point it to node port, let's say my traffic is coming to this one, how come the other port here, this will get served? So Kubernetes has its internal networking. So what it does is, even though you send your traffic, like the load balancer sends its traffic to this IP address, it will automatically redirect that traffic to this pod also. So these two nodes, they do have an internal bridge in place, so that should not be a challenge. I think so far we have what we have covered, like these three services mainly, or features, deployments, grievances, and services. These are clear to you guys. Please do let me know if you have any doubt, and I'll try my best to respond to that. And please do like and share. In the next series, we are just going to cover a bit more or detail about Kubernetes, how different kind of node configuration can be done, like taint and toleration, how exactly we can configure the service account, what a service account, etc, etc. So thank you once again for watching this. Please do like and subscribe. See you for the next time.